Hypothalamus artificial intelligence, HI. It presents companies in the process of digital transformation, its offer of professional services and the supply of algorithms of highly complex multi-problem mathematical models. These services are called Smart Grids, Forecasting Models. Lecture prepared by Engineer Jesus Velasquez Bermudez, Ph.D. Hypothalamus Artificial Intelligence, HAI, and the Research Center for Advanced Decision Technologies, RCA-DET, a private graduate academic center that uses artificial intelligence to complement advanced professional training, are pleased to invite you to watch the podcast of the course, Smart Grids Optimization. In 2014, IBM estimated that companies in the energy and utilities sector, which used big data and analytics, reported 23 times higher productivity than those that did not. The impact of smart grids and the Internet of Energy on artificial intelligence is very large. The consequence of this is to solve new mathematical problems through artificial general intelligence, that does not require centralized solutions or human participation. Smart grids. Load forecasting. Forecast renewable energy sources. They correspond to predictive analytics models focused on the prediction in the specific sites where are located the generation plants. Models are also affected by the timing of the prediction. Forecast of demand energy. Long run. Demand projections per weeks, energy and maximum power. Medium term. Demand projections per weeks, located in medium areas. Short term. Demand projections per days or hours, located in specific installations. As shown in the figure, demand-side management, DSM, programs can be done for three different categories of loads: industrial loads, commercial loads, and residential loads. In all the mentioned categories, customers respond to the time-varying prices. Compared to industrial and commercial loads, it is very hard to accurately forecast hourly energy consumption in the houses. Load forecasting. Performance measures. Performance measures. Mean absolute percentage error, MAPE, and mean absolute deviation, MAD. Demand management works to reduce electricity consumption in homes, offices, and factories by continually monitoring electricity consumption and actively managing how appliances consume energy. It consists of demand response programs, smart meters and variable electricity pricing, smart buildings with smart appliances, and energy dashboards, and combined, these innovations allow utility companies and consumers to manage and respond to the variances in electricity demand more effectively. Load forecasting involves working at the following levels: substation, transformer, feeder, section. Load forecasts are extremely important for electric utilities, especially after deregulation. They can help them save significant resources, such as purchasing, generation, sales, contracts, load switching, area planning, infrastructure development, capital expenditure decision-making. Short-term load forecasting at different levels. System level, provide forecasts for the entire region as the whole. Load pocket and transformer level, provide forecasts for a transformer or a set of transformers, and feeder level, provide forecasts for a particular feeder. Substation and transformer level load forecasting are based on. Transformer level load forecasting can be used as inputs for transformer rating calculation. It provides necessary warning for transformer overloading or overheating, and operators can take appropriate steps to transfer loads, such as protecting the asset. Feeder level load forecasting are based on. The goal is to provide the system operators with advanced warnings on potential feeder overloading. The forecasting can be used as inputs to feeder reconfiguration, and system-wide feeder level load forecasting can be extremely useful for operators to come up with optimal switching and load transfer decisions. Section level load forecasting are based on. Consider a feeder that is separated with a few switchers. Each separated segment is called a section. With AMI we can obtain load information for each section and each end customer. We also have information for each of the three phases, and These forecasting would be valuable inputs for optimal switching decisions and phase balancing. Load modeling and forecasting using AMI data. With advanced metering infrastructure, AMI, load modeling and forecasting can be conducted in an even more flexible and useful way, and at even lower levels, section or even customer level. This load modeling and forecasting provides valuable inputs to other distribution applications, such as optimal power flow, reliability simulation, feeder configuration, phase balancing, and voltage control. Modern methods are based on predictive artificial intelligence tools. This is how an ancient method, the Kalman Filter, created in the middle of the last century, is the best predictive hybrid artificial intelligence tool. It is easy to find examples in which the Kalman Filter outperforms traditional regression methods. Smart grids. Climate forecast. Creativity is just connecting things. When you ask creative people how they did something, they feel a little guilty because they didn't really do it, they just saw something. It seemed obvious to them after a while. Steve Jobs. Thank you for your attention.